Good day, my name is Tapelo Tototo. So today I'll be doing my presentation about the contour model as teaching aid and the design of the micro lesson. So here is just like an agenda of what the presentation is gonna be about. It's gonna be introduction, chosen landform, construction of the contour model, topographical map examples, completed contour model, and micro lessons. So the first one in this presentation, we will be covering two sections, which is question one and question two. Question one is like whereby we construct our contour model for one landform, and its comparison to the real topography that we normally use as geographers. And question two is like a basic micro lesson on a contour line using the model as teaching aid. So the landform that we chose is a mesa. A mesa is a flat-topped elevated landform with steep slide. It is formed by erosion and a significant feature of South African landscape. In this model, the mesa will be built with contour lines. These contour lines here are contour lines, layers representing a flat summit at the top, which is here at the escarpment slope. This landform was selected because it is a distinct and easy to recognize both on maps and in physical landscape. So we constructed this landform like this. We printed it and we traced the contour lines of the mesa from the topographical map, and we cutted the cut box according to each contour line interval, which is like the 20-meter space in between, and we stacked layers neatly to create what a 3D model. Contour code layers I made to be green on like the lower level and brown at the higher level. And the topographical map example is shown here in the presentation, which is whereby you will be able to see it when you are marking. I compared the mesa model, this model, to the topographical map, and the name of the town that I used is Beaufort West, and the map number is 3322 BC, and the coordinates is 32 minutes 22 seconds to the south. And then on the map, the mesa is represented by the concentrics, which is like a round randicular, which shows how their slopes are connected and how they are steep to one they are steep to one another, and then they are flat at the summit at the top of the mountain. And then the completed model is here, which I built and I pasted on the presentation. And then the micro lessons that I'm gonna be teaching to the learners is like, good day, learners, and today we are going to learn about contour lines and how they help us recognize landforms, and I'll be telling them how often people or anybody else who are studying or not studying wonder how height can be shown on the flat piece of paper, and contour lines are the answer. They join points of equal height. In this lesson, I will be using the 3D model of a mesa, understanding contour lines and see how they represent South Africa landscape. And the teaching and learning phase, part one. First, I will start by defining what is a contour line. Contour line are imaginary lines that joins points of equal height above sea level. When lines are close together, it shows a steep slope, and when lines are far apart, it shows that the slopes are gentler. And on the part two, we compare the mesa model with the topographical map. On the map, the mesa is shown by concentric contours with a flat top. On the model, you can clearly see the summit and the steep side. Discussion question that we're gonna have in the class is like, how is the meta different from the butte? And then the answer that's coming from the learners is gonna be like, a butte is smaller than the mesa. And then in conclusion, I can say contour lines are the language of maps that represent height. A contour model allows us to see landforms in 3D and 2D, which is on the map, in the topographical map. This mesa is an example that shows how contour lines become physical layers. Remember, 2D map is equals to 3D map, which shows you the real topographical map. Thank you for your attention.